We are going to evaluate an integral by parts, iterated once, and keep the visual steps perfectly aligned. The problem is, evaluate the indefinite integral of e to the x times sine x dx. First, recall the integration by parts formula. The integral of u dv equals uv minus the integral of v du. Now, first pass. Choose u equals sine x and dv equals e to the x dx. Then du equals cosine x dx and v equals e to the x. Apply the formula to get the integral of e to the x sine x dx equals e to the x sine x minus the integral of e to the x cosine x dx. We still need that remaining integral. Compute the integral of e to the x cosine x dx with integration by parts again. Choose u equals cosine x and dv equals e to the x dx. Then du equals negative sine x dx and v equals e to the x. So the integral of e to the x cosine x dx equals e to the x cosine x plus the integral of e to the x sine x dx. Now, we combine both results and solve. Let capital I be the integral of e to the x sine x dx. From the first pass, we have I equals e to the x sine x minus the integral of e to the x cosine x dx. From the second pass, the integral of e to the x cosine x dx equals e to the x cosine x plus I. Substitute this into the first equation to get I equals e to the x sine x minus e to the x cosine x minus I. Move terms to solve. 2I equals e to the x times quantity sine x minus cosine x. Therefore, I equals 1/2 e to the x times quantity sine x minus cosine x plus the constant c. We are done. The integral of e to the x times sine x dx equals 1/2 e to the x times sine x minus cosine x plus the constant c.
Thank you for watching. Tap like, share, and comment, and then follow and subscribe for more quick problem solving tips. Let's make maths simple, one video at a time, only on muyvibes.